Okay, so for 8.5, we're going to take all of the different types of plots, looking at all different types of data, and then we're actually going to analyze the data and determine which measures are better for us, depending on what our data looks like. And then, you guys remember stem and leaf plots? Vaguely from 7th grade. We're going to look at stem and leaf plots too. Okay, so let me give you a quick, we've already kind of looked at this where I give you a set of data and I ask you, is mean a better measure or is median a better measure, right? So we're actually going to write down when is better to use which one, and then also our spread. So let's talk about our measures of central tendency first. Our measures of central tendency are either mean or median. So central, meaning that we're looking at the middle part of our data. So you would use mean when the data is symmetric, and that's because since it makes that nice symmetric curve, if we calculate the mean, it's going to give us pretty much exactly the middle point, right? So the mean is the average of everything. So if our data is symmetric, meaning it looks something like that, then our mean is going to fall somewhere in the middle, and it's going to give us a good measure of about where our data is likely to fall. However, if our data is skewed, we're going to use the median. And the reason we use the median when it's skewed, so it would look something like this, is because all these outliers on the end are going to give you a mean that's either too high or too low. So your median actually gives you a better indication of where most of your data falls. Does that make sense? So if your data is skewed, you're going to want to use the median because most of our data is in that skewed portion, and the mean would give us too big or too large because of these outliers over here. Okay. So then let's talk about spread a little bit. Spread is either inner quartile range, IQR, or standard deviation. So both of those measure how spread apart the data is from the middle. Standard deviation, remember, has to do with how far the data is from the mean. So if our data is symmetric and we're using the mean as a measure of center, then we're going to use standard deviation as our measure of spread. Okay? So because standard deviation has to do with the mean, when we're using the mean, we also use standard deviation. Okay? So then if our data is skewed, we don't really care about the mean because it's not a good measure. So we're going to use IQR when the data is skewed because that just has to do with the box in your box and whisker plot. So for the first example, I'm going to give you a set of data. It is a very, very large set of data. I do not expect you to copy down the entire chart, okay? But what we're going to do is I'm going to have you guys in your groups do a box and whisker plot for that set of data, and then we'll answer some questions about it, okay? So I'll read you the question, I'll show you the data, and then I'll put it up so that you can see the actual question. So each participant in a track meet and the number of gold medals that each participant won is represented below. So on the left, I tell you what their participation number was, and then I tell you how many gold medals they won, okay? I'm going to put this on the board for you while you're constructing your box and whisker, but I'll have you get set up first. So your instructions here first are going to be to construct a box and whisker plot of the data and include any outliers. So I want you guys to make your line first for me. It goes from 0 to 14, and then I'll put the data up and I'll have you construct your box and whisker. So you're going to need to calculate your 5-number summary with the people in your group. You guys can all work together. And when it says include any outliers, that means that if you need to, let's do the 5-number summary first. How about that, okay? So, and then we'll do the outliers together. So here's your set of data, and do the 5-number summary for me, please. Okay, so with your data, I'll put it up here, and I just want you to do the 5-number summary for me first. Okay, guys, what did you get for the minimum? 0? Okay, what about the maximum? 14, okay. So minimum, maximum, what was our median? Does it fall directly on 4, or is it in between two numbers? It's between 3 and 4, so that means it's going to be 3.5, right? So it would only be 4 if it landed exactly on 4. Otherwise, we have to be in between the two, so 3.5. So that makes Q1 what? 1, and then Q3 is, what's Q3? 6. Okay, so our set of data tells us that we need to include any outliers, so meaning we need to put a little asterisk next to where the outliers would show up, so we don't want to include them necessarily in our whisker part of it. So in order to find outliers, what do we need to find first? Upper fence and the lower fence, which means we need to find IQR. So IQR, I'm going to do my work off to the side so I don't run out of, or I'll do it down here. IQR. How do we find IQR? Q3 minus Q1. So IQR is going to be 6 minus 1, so our IQR is what? 5. Okay. So then to determine if we have outliers, we need to find the upper, what? Fence and the lower fence. Does anybody have those memorized yet? Just out of curiosity. Q1 minus, oh, good job, guys. Q minus IQ, or minus IQR times 1.5, and then upper fence is the same thing, but, good job, guys. Okay, so it was Q3 plus IQR times 1.5. A couple people have asked me, where does 1.5 come from? To be honest, I don't really know the mathematical reason. I'm thinking that if 1.5 is the same as 150%, right, if you move the decimal over, and so some statisticians at some point decided that 150%, that is way too much, and that's the furthest acceptable limit. So it's just kind of, we had to pick a limit, and so they picked 150%, or 1.5, okay? So what I want you guys to do right now is calculate the lower fence and the upper fence for me. If you need to use a calculator, you can to do the multiplication part, but calculate both of those, and we'll determine if there are any outliers. Okay, what did you get for lower fence? Negative 6.5? Okay, so would there be any outliers on the lower part? No, because is it possible to get negative gold medals? Okay, what did you get for the upper fence, though? 13.5. So were there any outliers in the upper part of your data? Yes, which one? 14 is an outlier. So 14 is an outlier, so instead of including it in our data, we're going to put an asterisk, or that little star, at 14, and then we're not going to include it, okay? So we'll put the little star there, and then let's make our box and whisker. So our minimum was 0, so we're going to start at 0 and put our first line. And where does Q1 start? At 1. So our box is going to go from 1 to Q3, which is 6, right? So our box should look like that. So let's connect the whisker on the left. Where is the median, guys? 3.5. So that's going to, here's 3, so it's going to be in between 3 and 4. And now that we took the outlier of 14 out, what would the next biggest number be? Is it 10? So your last part of the whisker is going to go to 10. So our whisker is going to go from 6, which is Q3, to 10. Okay? Our outlier is still indicated, but the star shows us that it is an outlier. Okay? Otherwise, we'd have that wicked long whisker, right? The last thing we need to do for our box and whisker, and on your test, I'm going to be really picky about this, nothing is labeled here. What do all of these numbers indicate? What does 0 to 14 mean? Number of gold medals. So you do need to label that, okay? So this is going to be number of gold medals. If you want to put it at the top, that's okay if you don't have enough room. Typically, we put it underneath the number line just so it tells you what each number means, but if you don't have room, you can put it at the top right now. Okay, so that's the number of gold medals. Okay, so my question to you, which measure of central tendency and spread should you use to describe it? And then we've already calculated everything, so we'll just have to write it all down. Is this data skewed or is it pretty symmetric? It looks pretty skewed, and the reason I can tell is because this whisker is super short and this one is still pretty long in comparison, and my box is kind of to the left. So what direction is this skewed? Skewed right. Remember, skew means that there's less data on that side. So what measure of central tendency would we use? Median, and what kind of spread? IQR. So we should use, let's write that down, we should use median and IQR because, and make sure you write why, because the data is skewed. Okay, let's make it more specific. Let's say it's skewed right. Okay. And then we already calculated median and IQR. Okay. So let's just rewrite it. Median equals 3.5 and IQR was 5. Okay. So if your data is skewed, you use median and IQR. If your data is symmetric, you use mean and standard deviation. If I was to find the mean, would my mean, because this data is skewed right, would my mean be bigger than the median or would it be smaller than the median? Smaller. No, bigger. It'd be bigger because these guys would skew the mean to make it bigger, right? So my mean, if I were to find it, would be somewhere over here bigger than the median, which is what we don't want, okay? If it was skewed the other way and the outliers were on the left, my mean would be smaller, okay? That's why when it's skewed, we want to use the median. Does that make sense? Okay. So let's talk about stem and leaf really quick, and then we'll look at some stem and leaf plots. So we have done stem and leaf before in 7th grade, but then I'm going to introduce you to a new kind of stem and leaf plot also. So first, a stem and leaf plot is a graphical method used to represent ordered numerical data. So the data is already ordered for you. The stem is all the digits in the number except the right, which is the leaf. Okay, so remember the stem is like your tens place and the leaf is like your ones place. So stem and leaf plots, if you guys remember, look like you have a left column that has all of your tens places and then the leaves come out on the right, but everything's already in order for you. But we're also going to look at what is called a side-by-side stem and leaf. So a side-by-side allows a comparison of two data sets. So you have your stem in the middle, and then your leaves are going to go off of each side, and you'll see what I mean when I show it to you. So the two data sets, they share the same stem, isn't that nice of them, but have leaves to the left and right of the stem. Okay, so the leaves are either to the left or right, one for each set of data. No. Okay, so for this example, data was collected from two rival airlines, measuring the difference in the stated departure time and the times the flight actually departed. So they took what time they were supposed to leave and what time they actually left. And then the average departure time differences were recorded for each month. So in 1 month, they were only 7 minutes apart. In another month, the average was only 8 minutes apart. So like I said, in 7th grade, you looked at stem and leaves with just one stem and then one set of leaves. And then they give you a key at the bottom. So 2, 4 means 24 minutes, okay? So this would be 7, 8, 14, 15, 16, 24, 27, 29, and so on. A side-by-side stem and leaf shares the same stem, and then the leaves go off in two separate directions. So for my airlines, we have 0, 0, so it left exactly on time. 0, 5, so 5 minutes, 1, 1, so 11, 15, 19, 20, 20, 26, 33, 33, 34, and then 40. Okay, so you read it exactly the same, just on the left goes backwards, on the right goes the correct way, but it's two sets of data side by side. All right, so the first thing I want to know is I want us to describe the distribution of each set. So first let's look at my airline. Okay, look at how the data is distributed. So do you guys see that it's kind of like a dot plot because it gives you each individual piece of data? So it's kind of low in the zeros and pretty low in the fours, but then most of my data is right here in the middle. So what type of distribution would you call that? Symmetric? I think it looks pretty symmetric because if we were to draw like that hump over it, it's still pretty symmetric. It's not always going to be perfect, but if most of your data is in the middle, we're going to call it symmetric. So let's say that my airlines is symmetric. My airlines. My airlines, whatever. Okay, what about Fly High Airlines? We have not a lot at the bottom, not a lot at the top, but most of our data is kind of in the middle. Would you guys call this one symmetric? Yeah. Yeah, I would say it's pretty symmetric, and only because the 2 and the 1 are about the same. And so even if we were to draw the hump over it, it's not like we had a whole bunch at the zeros and then nothing at the top. Does that make sense? So I would say that that one's also pretty symmetric. I think that it's not enough data to be considered skewed one way or the other. So my last question is, based on the shape of each data, what is the appropriate measure of central tendency and what is the appropriate spread for each one? Both of them are symmetric. So what would be the appropriate measure for each? Mean and what goes with mean? Is it IQR or standard deviation? Standard deviation, okay? So mean and standard deviation are a better representation. Remember, mean is X bar and standard deviation is sigma, which is the kind of like the cursive O. It's the Greek letter sigma, lowercase. So mean and standard deviation for each one. Here's what I want you guys to do. Calculate the mean for each of them, and then we'll do standard deviation together since there's a lot of pieces of data, okay? So I'm going to have you guys do the means, so get a calculator or something so you can do the mean, but because there's so much data, doing standard deviation by hand would take forever, so we'll do it on the calculator for this one, okay? Okay, so what did you get for the mean of my airline? Ooh, we're getting some different stuff.
I got 20.3.
I got 21.33. So you have to include 0 in your data. So even though it doesn't make a difference when you're adding it all up, you still have to include the 0 on when you're dividing.
Wait, also, it might not count.
So remember, standard deviation, you take each piece of data, subtract it from the mean, square all of those, do the mean again, and then take the square root of that. Okay, so you will be able to use a scientific calculator on your test to help you with those, but you can't plug them into the graphing calculator and just spit out the answer because they're going to be small pieces of data, like 4 numbers. So if you were to go through all of those steps with these 12 pieces of data, which would take you forever, you should get a standard deviation of 11.83. Okay? Did anybody get the mean yet for Fly High Airlines? 20.92. Anyone disagree? I got 24.67. 24. I got 24.67. Okay. And then same thing, standard deviation. You subtract each piece from the mean. You square that. Take the mean of those numbers, and then square root it, and you should get 12.86. So what might be helpful is if you go home tonight or sometime this weekend, do the standard deviation by hand for both of these and see if you get both of those numbers. But which one, is it My Air Airlines or Fly High Airlines? Which one has a lower standard deviation? So they should be more consistent, right? So that means that their data is more tight together and Fly High Airlines was more spread out, which kind of makes sense if we look at it, right? In My Air Airlines, most of their data is in the 10s, 20s, or 30s, whereas Fly High are a little bit more spread out, right? So if we were to look at the data, we should be able to guess that My Air has a lower standard deviation because the data is more close together. Does that make sense? So if the data is closer together, it gets a lower standard deviation. If it's more spread out, it would have a higher standard deviation. Okay?